This movie is about date and time functions. It's about a lot of date and time functions, 22 of them to be exact. Beginning with the date function, which will return the serial number of a particular date that's built from different values in different cells for the year, month, and day. The date value will convert a text date to a serial number date, an actual date. Time will convert some particular values, hour, minute, seconds, into a serial number that represents the time, and time value will convert a text into a serial number time. The weekday function converts a serial number to the day of the week, Monday, Tuesday, Wednesday, etc., the 1st, the 2nd, the 25th, etc. The week num function returns a value that equals whether the week in the year is the 1st, the 2nd, the 10th, the 20th, etc. The eDate function returns the serial number of a date that's offset from a start date, a given number of months. The EO month function returns the end of the month that's offset a number of months from a given date. The now and today functions are volatile functions. Now returns a serial number that includes the time and the date. Today returns a serial number with just the date. Second, minute, hour, day, month, and year. Take a serial number and return either the time in terms of seconds, minutes, or hours, or the date in terms of day, month, and year. Day 360 allows you to convert a standard year into a 360-day year. Year frac will return the fraction of the year represented by the span of time in between two dates. Workday and Workday International will give you the number of work days beginning at a starting date that you define after taking into account the holidays, which you also define. Network days gives you the number of work days after taking out the holidays between a starting date and an ending date. So I know there's a whole lot of information in that introduction, but stick with me. It's not as complicated as it might have sounded like it is. We're going to start with the date function. The date function has three arguments: the year, the month, and the day. And there are some rules that Excel applies to those input values. But really the easiest thing to do, instead of remembering those rules or what may happen when you enter a number that's larger than 12, for instance, for a given month, is to just be literal with it. So I'm going to input a date function, D-A-T-E, tab, and make cell D16 the input for the year, E16 the month, and F16 the day. I'm going to enter, and of course that's going to be an error because I have no values there. And like I said, I'm going to be literal. 2013 is the year, 2 is the month, 25 is the date. That's actually today. And Excel has done a couple of things here. One is that it has formatted that cell, C16, as a date, because if it wasn't a date, it would be general or a number, which that is a serial number that represents that date, and that is the value that is being returned by the date function. And when we format that cell as a date, we see the date. The date value function takes a text string, which I'm going to begin with a quote, 2/25/2013, enter, and that is not a date. As you probably know, I can't convert that to a number, and since it's not a number, it's not a value, and if it's not a value, it's not a date, not really. And I'm going to go into cell C20 and enter the date value function, which is going to convert that date in the form of text to a serial number, and that should look familiar because we just saw that. When I convert that to a date format, I've converted this text string that really isn't a date in Excel's world to an actual date. Moving on, for the next two, time and time value, work similarly to date and date value. The time function has three arguments: the hour, the minute, and the second. And again, there are limitations as to what you can put in terms of values for those times. And like the date function, the time function, and I'm going to define those arguments to be cell E15, F15, and G15, enter, and Excel has returned to me 12 a.m., the beginning of a new day, which is really the equivalent of 0. That's what that would be. For the hours, I can put a number anywhere in between 0 and 30,000. So I'm going to put 1 in there. and it's 1 a.m. 25 is actually 1 a.m. as well, because the time starts at 0 at 12 a.m., and then you continue around the clock for how many hours you move forward. So if we move forward another 24 hours, which is going to be 49, it's still 1 a.m. The number of minutes works sort of the same way. If we put 60 minutes in there, it's going to be 2 a.m. We put 62 minutes in there, it's going to be 2 minutes after 2 a.m. And seconds works the same way. The limitation, the upward limitation for these arguments is 30,000. But as in the date function, if you're as literal as you can be, and I'm going to input seconds, let's put 25 seconds in there. And I'll have to reformat the cell to see those seconds. 49 hours, 62 minutes, and 25 seconds after the beginning of any day is going to be 2:02 and 25 seconds into whatever day we end up on, which would be, 3 days after the beginning day. The time value function, similar to the date value function, will convert a text into a serial number time. So I'm going to input time value, tab, and reference cell E19 as the argument, and of course that's going to be an error. If we have a text entry, 2:02 a.m., enter, this entry is not really time because it's a text entry. But the time value function, just like the date value function, will take that text entry and convert it to a serial number. And when I format that cell as time, we get our time. So the weekday and the week num function. Looks like there's a lot going on here, but it's pretty simple, straightforward actually. The weekday function converts a date in the form of text serial number or some other number that's a result of some calculations to a day of the week that's represented by a number, 0 through 6 or 1 through 7. The default is to start the week out on Sunday, so Sunday will be 1. But there's a bunch of other choices you have as to when you start your week out. So I'm going to put a weekday function in cell C13, tab, and I need to reference a date, which I'm going to input into cell D13. And for the time being, the return type, which is an optional argument, I'm going to leave blank. Control Enter. I get 7, which is interesting because I don't have a date in there yet. I'm going to input a date, 1/1/2013. Enter. And I can see from the dates I have listed below that the first of the year, 2013, is a Tuesday. If Sunday's 1, Monday is 2, and Tuesday is, of course, 3. And the weekday function will return a number even if the content in this cell is text. Putting an apostrophe before that date, Control Enter, converts that to text. It's now no longer really a date in Excel's eyes, but it is a date in the eyes of the weekday function. The return type, I'm going to reference cell E13, Control Enter, and of course the function returns an error because I haven't defined a return type yet. I've got a validation set up that's referencing the numbers that are in column K, so we can kind of walk through some of these. That equals the default, which is 1. Tuesday is a 3. Tuesday's now a 2, which means Monday's a 1. You can begin the week out on Monday. Choice 11 is still a 2. Choice 13 is a 7. Choice 14 is a 6. So what do all those look like? There are 10 different options as to when you begin your work week out. Now some of these options return the same result. Number 2 and 11 will both make Monday a 1. Numbers 1 and 17 will both make Sunday a 1. Escaping out of that and onto the week num function. The week num function will return the number of the week for a given year. So if it's the third week of the year, it'll return 3. So putting a week num function in cell C19, tabbing, and referencing the dates that are in column D, Control Enter, the week num function returns a 1, which would make sense. The first day of the year is in the first week. But watch what happens when I copy this down. The week num function tells me that there's only 5 days in the first week. Well, that's where this optional argument comes into play. I'm going to select all of the cells and go up to the formula bar and change all of these functions at the same time. So we know the first of the year is actually a Tuesday. So I'm going to set this optional argument to equal 12, which is Tuesday. Control Enter. And now my week has 7 days in it. So that's what the optional argument is for. It's to establish what day the year began on. Moving on to the eDate and the EO_month function. Both of these have the same arguments. They don't yield the same results, but they have the same arguments that are required for each of the functions. I'm going to put an eDate function in cell F15 equal ED tab. The start date is going to be January 1st, 2013, and I want to offset that date by 2 months. This should return March 1st, 2013. Doesn't look that way because we get our serial number, which we'll have to change the format to the date format. Now we see March 1st, 2013. So the eDate function goes either forwards or backwards in time, because I can put a -2, and we'll get November 1st, 2012. And you might be wondering, well, what happens when there's a date like the 31st of January and the offset month doesn't have 31 days? When that happens, the offset month shows the number of days it actually has. In November, there's only 30 days, and in February, there's only 28 days. So if your start date is the last day of the month, each month that you offset from that start date will show the last day of the month, which is the result you'll get all the time when you use the EO_month function, equal EO_month. I'm going to use the same start date, and I'm going to advance it by 1 month. We get the serial number again. I'm going to copy the formatting down here so we can see a date. Currently, we have both functions returning the same result, but when I make this date January 15th, the eDate is offset by a month exactly because it takes me to February 15th, and the EO_month function is offset by a month, but it gives me the ending date of that month. The now and today functions, which are both volatile functions, which means, one, they don't have any arguments that are required, and two, they'll recalculate every time you recalculate the workbook, return the current day in the case of today, or the current day with the current time in the case of now. So I'm going to put a now function in B16 equal NOW, tab that into the cell, and enter, and I get the current date, 2/25/2013, and the time in military time, it's 7:15. Arrowing down a couple cells. If I instead use the today function, I'll get 2/25/2013 without the time. The next three functions are fairly straightforward and easy. You may never need to ever do this, but if you need to do it, you can, and that is to pull out from a time the seconds and the minutes and the hours. So to quickly demonstrate this, I'm going to link cell F16 to the value that's in F13, Control Enter, and then input the second function in cell D16 and reference F16, enter twice, put the minute function in cell D18 and reference F16, and then the hour function in cell D20, again referencing cell F16, and then enter. And the last thing I'm going to do is format cell F16 as time. So 0 becomes the witching hour, 12 a.m., the 0 hour. And when I put a value in cell F13, I'm going to put a small decimal in there. 0.009 is 9/1000 of a day, or converted in terms of time, it's 12 minutes and 58 seconds after midnight. The second, minute, and hour functions have pulled from that time the seconds and the minutes and the hours. This again underscores the fact that times and dates are all serial numbers. They're all values. I'm going to put a bigger number in there, 0.25, which should be 6 o'clock, because it's 25% of a day, which is 6 a.m. in the morning. The seconds and minutes are 0 and the hour is 6. Just putting one more value in there, 0.255, enter, and the second, minute, and hour function pull out the second and minute and hour of that particular time. The day, month, and year function work the same way as the second, minute, hour function. I'm going to link cell F13 to F16 and then put a day function in cell D16 referencing F16, enter twice. Put a month function in cell D18 referencing F16, enter twice, and put a year function in cell D20 and reference F16. And then the last thing I'm going to do is format cell F16 as a date. So once again, we see the serial numbering system at work. 0 is January 0, 1900, because 1 is January 1st, 1900. 2 is January 2nd, and so on. And 1000 is September 26, 1902. The day function pulls out the day from the date, the 26th. The month pulls out September, the number 9. And the year pulls out the year 1902. So the next two functions, the days 360 and the year frac function, is what we're going to look at next. The days 360 converts a regular calendar 365 or 366 day year into a 360 day year, albeit it does it a bit imperfectly. I'm going to select all of those cells to make the input a little bit easier and begin on January 1st, 2013 and end on December 31st, 2013 to cover the entire year. And the second pair of cells, I'm going to cover half of the year, 2013, and end on June 30th, 2013. And the third pair of cells, I'm going to pick up the other half of the year, which begins on July 1st, 2013, and ends, of course, on December 31st, 2013. Enter. In column L, I'm going to calculate what the actual number of days in between these two dates are, and I'm going to have to add 1 because I want to include the first day. Control Enter. And it's 365 days because 2013 is not a leap year. And that gets split up between the first part of the year having 181 and the second part 184, which of course equals 365. So what does day 360 tell us? Putting a days 360 function in column N, I've got a start date of January 1st, 2013, and an end date of December 31st. And the optional argument, the method, just has two different methodologies on how days 360 will calculate and convert a regular year into a 360-day year. I'm going to ignore that, though. Control Enter. And for the entire year, days 360 is perfect. It's spot on, 360 days. But for some reason, when you split up the year, days 360 tells me the first half of the year had 179 days, and the second half of the year it had 180 days. And there's obviously two problems with this. One, days 360 returns a different result for the entire year than you get when you add up what it returns for the first half and the second half of the year. And the first half of the year is not right if you're actually tracking this and trying to convert the first half of the year into a 360-day year. It should be 180 days. So you got to be a little bit careful when you're using this. And the days 360 function will work whether the cells referenced contain an actual date with a serial number or whether it's text that looks like a date. And converting January 1st, 2013 to a text, I see that my function has returned the same result. So year frac also takes serial numbers, text content that looks like a date, or other calculated amounts that equal a date that's assigned by that serial number. So what does the year frac do? The year frac just gives you the fraction of the year that two dates, the beginning date, the start date, and the end date, represent. The basis gives you some methodologies to use when you're determining the fraction of the year. And again, we can use a 360-day year to do that. I'm going to ignore that for the time being. Control Enter. We get 1, which is what we would expect to get. That's the entire year. Copying down, we get not quite a half a year, and then copying down one more time, we get exactly a half a year. So once again, we have year functions that are presenting us with a calculation for the full year that doesn't equal what the calculation adds up to for the first half and the second half of the year. More date and time functions, the Workday and the WD.INTL function. Instead of describing the Workday function, I'm going to show you the Workday function. I'm going to select a cell, G14, and enter a Workday function. Tab. The Workday function has 3 arguments. One of them is optional. The first one is a start date. I'm going to pick the content that's in cell J14 as a start date, comma, and then the days are the number of days that you want to elapse between your start date and the next working date. The Workday function assumes that you get Saturday and Sunday off, so it's a standard work week, and for the time being we're going to ignore holidays. Control Enter. So if I begin on the 5th and I want the first work day after the 5th, that first work day is going to be on the 7th or a Monday. If I want the third work day, the third work day is going to be on a 9th or a Wednesday. And if I do define a holiday, and I've just sort of made one up and called it holiday, Control Enter, the third work day after the 5th of January is going to be the 10th or a Thursday, because Monday the 7th was a work day, but I've defined it as a holiday, so the Workday function skips that day and returns Thursday as the third workday after the 5th, which is a Saturday. So the Workday.INTL works similarly. So I'm going to enter Workday.INTL into the cell. And once again, I need a start date, and I'm going to use the same start date as I did before. I need the number of days, and once again, this number is going to be the 100th working day beginning on the 5th of January. Comma, the next argument is your ability to define the weekend. The standard weekend is Saturday and Sunday, of course, but your place of work may be different. There's some limitations here. You either have the option to choose 2 consecutive days off or 1 day off. And of course, every place of work doesn't function that way exactly. I'm going to choose the standard weekend, which is Saturday, Sunday, which is option 1. And finally, we get to choose holidays. And I've downloaded off the internet every nationally recognized day, whether it's a holiday or not. I mean, I know I don't get Belly Laugh Day off. You might, but I'm going to select all of those, Control Enter, and page up to get back to the top, and then reformat that cell as a date. So the 100th working day after the 5th of January, with a work week that's defined to have Saturday and Sunday off, and a whole slew of holidays that are also granted to the employees, is the 7th of June. The final 2 date and time functions are network days and network days INTL. These functions are similar to the 2 we just covered, except that instead of finding the next working day after a given number of days, these functions tell you the number of working days in between 2 dates. So selecting cell G14, tabbing the network days function into the cell, I need a start date, which is going to be January 1st, 2013, an end date, which is going to be December 31st. And for the time being, I'm not going to define the optional argument holidays. Control Enter. There's 261 standard work days in 2013. That's a work week that's defined by Monday through Friday, where Saturday and Sunday are not work days. F2, going back in, comma, I'm now going to define my holidays to be this laundry list of nationally recognized days. Control Enter. And now we have 234. So the difference is 27, so we should find 27 holidays occurring on Monday through Friday. And the list tells us that there's 29, but that's because we have two instances where we have two holidays on the same day. On the 1st of April, we have April Fool's Day and Easter Monday, and on the 12th of February, we have Lincoln's birthday and Mardi Gras. So net Workday's INTL works almost the same way, only this function, after you define a start and end date, allows you to determine or define a weekend, which may be 2 consecutive days, doesn't have to be Saturday and Sunday, or it might be 1 day a week. I'm going to select the default Saturday and Sunday, and again select our holidays, and we should get the same answer, and we do. So those are the date and time functions. We looked at the date function, which returns a serial number for a date. We looked at the date value, which converts a text to serial number. Time returns a serial number for time. Time value returns a text into a serial number that represents the time. Weekday converts a serial number to a day of the week. Week num will define which week of the year that you're in. E-date will take a given start date and offset it by a given number of months. EO month, end of month, will take a given start date and offset it by a given number of months, returning the last day of the month. Now returns the current date and time. Today returns the current date. Both of those are volatile functions. Second, minute, hour, day, month, year takes a date and time and returns that component of the date and time. Day 360 converts a year to a 360-day year, and year frac will return a given number of days and what span of time that represents as a fraction of a year. Workday will return the date that's the X number of workdays away from a start date, and net workdays will return the number of workdays given a start date and an elapsed period of time defined by the number of days.